Hello, my name is Andrew Just, and in this module we'll discuss and dealing with non-precipitation types in both the probability weather type methodology and forecast builder. So a little review here. What are the non-precipitation types and how is weather created? So on the left here is a listing of the various coverage grids, such as probability of fog, probability of frost, smoke, etc. And the values in these grids, they're scalar 0 to 100%, just like the precipitating types. They correspond to a specific coverage verbiage, such as if you were to put in a 40% probability of blowing sand, you will get areas of blowing sand. Similarly, 20% probability of fog is patchy fog. Then there are some special types. In these cases, like thunder and waterspout, where if you were to put a 20 value on thunder and kind of still stuck it in that non-precipitation types on the left, you would end up with patchy thunder, and that's not what you want. So thunder is always verbed with like slight chance, chance, likely, or isolated, scattered. So that's how this works, is that if you put a 20% probability of thunder in, it goes to slight chance or isolated into the weather grid. Now to preface a little bit before getting into the tool discussion, most of those tools mentioned in the slides ahead are embedded within the non-precipitation type step of forecast builder as shown here. The first one here is about probability of thunder, and we're going to do this via POP, and that can be done with the procedure pot_thunder located under the edit menu, and that's also embedded within forecast builder. And here's an example of what that looks like. You can copy the POP directly to the pot thunder, and you can specify at what POP to start mentioning thunder. And you can also limit how high the probabilities can go. So for example, if I only want isolated storms, I bring that maximum value down to 20, and that will cap it. A second way we can do this is via the models to produce the thunder grids. Within Forecast Builder can blend model probabilities together from the SREF, the gridded lamp or G-lamp, and MOS guide. So big positives there's a decent amount of science and statistics going into these grids. And so they will do a good job at delineating both the area and to some degree the coverage. But one of the drawbacks is that the values to these can be too low because of a combination of like calibration, in the case of the SREF, and different definitions, also because like the SREF where it's looking at cloud to ground lightning versus total lightning, which is something probably we're close to needing in the forecast builder and the prediction of the weather grid. So now here's adjusting for severe storms. The POT severe grid is available, which can be used to introduce T+ into the weather grid. Note that the values in this grid need to be greater than or equal to 30%. And gives you the ability here again to delineate in both in time and space where the severe storm threat would be. There's still tool development needed for the POT severe grid. There's a couple options that we could do with SPC convective outlooks, but they're 24-hour based. There's these SPC SREF calibrated severe probabilities, which are in forecast builder, but according to SPC they're still in their infancy, so they may not be the best to use either. However, should a severe thunderstorm or tornado watch go into effect for a portion or someplace in your CWA, the T will get automatically raised to T+ in the weather grid. So let's do an example with the thunder and severe. We'll take a fictitious line of showers in the POP grid, and we'll assume that all these showers are producing thunder, which is probably a big assumption. It's probably more spaced out than that, but we'll roll with it. We'll run that pot thunder procedure and produces that. There's your line, pretty much identical. All right, now to take another level, we'll say some of these storms are severe. Obviously you don't want the whole line to be severe, but some. So we're going to take that pot thunder grid, slash it by a third, so you end up with this line of 20 to 30% or so. And then that, when you merge it, will give you the weather grid as shown in the bottom right here. And that area with definite T+ here is your severe area, as shown in the POT severe grid on the left. Next is about pot fog. Forecast Builder has the ESTF Fogger tool built right in to help with creating the pot fog grid. And this is that fogger tool. Ensures the fog integrity with both your temperature, your dew point, and your wind. And this is the default tool in Forecast Builder when aviation configuration is turned off. Now there's another way that you can get pot fog into your grids is via from the visibility, and that can be done from the pot fog from Visibility Smart tool, which is embedded within Forecast Builder when aviation is turned on. And third way we can get fog into the pot fog grid is via these procedures underneath the edit menu called pot valley fog and pot marine fog. And here's an example of that procedure. And the nice thing is, so that if you're in an area that you're typically dealing with valleys, getting fogged up or whatever, not only will you get a visibility grid adjustment, but it will also adjust your cloud-based primary and your sky cover as well. And that's shown there. Now into sprinkles and flurries. There's a procedure underneath the edit menu called pot create sprinkles flurries. Again, this is embedded within Forecast Builder. Very simple GUI here. First, enter a coverage value. Right there, and there's some examples provided. So if I just want a chance of flurries, just put a 30 value in. Using your pop and hourly temperatures, as shown there, you can define the location for sprinkles and or flurries. So if you end up with both happening at the same time, you can use these temperatures to help you out in that regard. And important note here that both the flurry sprinkles aren't going to be mentioned when the pop is greater than or equal to 15. That's when you start to see all the other precipitating types kick in. Then there's a frost tool provided. It's called the pot create frost grid smart tool, which is also embedded within Forecast Builder. And this is based on a University of Kentucky Ag Department study. And you're going to utilize temperature, dew point, wind, and sky to create frost. Another tool here for blowing snow called pot create blowing snow, which is also embedded within Forecast Builder. This employs a combination of the Bagley snow model and research at ARX. There's in the Forecast Builder training a good module on blowing snow that you should definitely take a look at. And here's an example of what would be coming out. So if you had the tool producing 30% probability of visibility below 1 mile, you'll get an area's coverage. You also have the option in there to force a blizzard situation, and the values there of greater than or equal to 80%. Another tool here, freeze and spray. There was a tool called Freeze and Spray Forecaster for the Great Lakes offices. This is built right into Forecast Builder. It computes pot freeze and spray and pot heavy freeze and spray using grids like temperature, wind, and wave height, and lake surface temperature. And where ice exists, and this is defined by the ice edit area, no freeze and spray will be produced. A few other non-precipitating types to be aware of. You'll need to create these grids manually and assign values. There's research and tool development requested here. Some ideas, something like smoke from visibility, satellite, and wind. Also, the HER is providing some smoke guidance, so that's an option. Haze, utilizing temperature, dew point, and wind. Blowing dust from wind. So again, there's room for improvement. And with that, if you have any questions or feedback, feel free to email me at the address shown. Thank you very much.